Hey everyone, today we're going to start our notes on exponent rules. So exponent rules are something that you guys are going to have to know for algebra next year. They are not on the Math 8 SOL at the end of this year, but they're going to be really important for high school. So they're a little bit challenging, so we need to make sure that we're listening to all parts of the video, filling in your notes. Every time I move a box, there's going to be something underneath that you need to fill in your notes. And you want to make sure that you're writing all of this down. And if you have questions, please raise your hand and ask during the video. You can always pause and rewind and re-listen to things and see if they make sense the second time. Okay, so the first thing we're going to do is product of powers. You don't need to remember this name, but it's just something that we're multiplying two bases that are the same. Okay, so here we have two bases, 3 to the 5th and 3 to the 4th, right? Our base is 3, we have the same base. So expanded form is the first thing we're going to write out. Expanded form is kind of annoying, but it shows you all the multiplication that would be written out if we were to write this fully. So like 3 to the 5th is 3 times 3 times 3 times 3 times 3 5 times. And 3 to the 4th is 3 times 3 times 3 times 3 4 times, right? So all of this multiplied out is this just written completely separated. In exponential form, right, if we're multiplying 3 5 times and then 3 4 times, all together we're multiplying 3 to the 9 power, right? We have 9 3's here. Okay, so 3 to the 9th is exponential form, it has an exponent. And then standard form is actually just solving it. It's 19,683. Okay, when we multiply 3 to the 9th, you can always use your calculator and use that button, YX, right? It's right above the division symbol, to do 3, then hit that button 9, and then you get your standard form. Okay, so again, we can do this. Just showing you another example. This time our bases are negative, but it doesn't change anything. We're still multiplying them all out, right? Negative 2 times negative 2 is negative 2 squared. Negative 2 times negative 2 times negative 2 is negative 2 to the 3rd. So all together, we have negative 2 to the 5th power. Standard form, solving it out, would be negative 32. Hopefully we're starting to see a pattern where we won't have to write our whole expanded form. Okay, but just one more, just in case. We have a lot of x's here. So we want to be careful. We don't have negative x multiplied 10 times. We have one negative, and then that 10 is applying to the x, not to the negative. If this was in parentheses, it would be negative 10 times negative 10 times negative 10, so on and so on, and do it 10 times. But since it's not in parentheses, it's just one negative and then 10 x's, and then we have 13 x's. So hopefully you can guess that all together, oh, I forgot my negative. All together we have negative x to the 23rd, right? We want to keep that negative out in the front. Sorry, I forgot it when I was typing this. But it's negative x to the 23rd because we have 23 x's. Okay, so hopefully we saw a pattern in our exponential form so that we can jump straight to this, to this. Okay, if our bases are the same, right, 3, 3, negative 2, x, x, those are the same bases, you keep the same base over here, and you add your exponents, right? 3 plus 4 is 9, 2 plus 3 is 5, and 10 plus 13 is 23. Okay, so we don't have to write this whole middle part. We can if it helps you, but we can kind of use our rule to jump straight to our answers over here. Okay, so let's do some practice here. Before we do our practice, actually, we're going to write it in a fancy way, okay? N to the a power times n to the b power is the same thing as n to the a plus b, right? It's just showing you we're adding those exponents, okay? If we have coefficients on our variables, okay, if we have an x or a y that are numbers, you would multiply those first. Like if this was a 3 and that was a 2, then we'd multiply and we would get 6, right? X times y is first. And then n to the a times n to the b is still going to be adding our exponents. If this is confusing, don't worry about it too much. We're going to do some examples down here, and hopefully it'll make more sense once you see some practice problems. So b to the 8th times b to the 2nd, we're going to add those exponents and we get b to the 10th. Pretty simple, right? Keep your base, add your exponents. Here, same thing. We're going to add our exponents. The one that's a little bit trickier, if you don't know, if you see no exponent here on our y, it's just a 1. Okay, anytime you don't see an exponent, it's a 1. Okay, so if we're adding our exponents, 9 plus negative 3 is 6, plus 1 is 7. So our final answer here is y to the 7th. Number 3, we have coefficients, right? We have this negative 7 and 9 out in front. Okay, so just like I said up here, x and y, those are our coefficients. We want to multiply those just like normal, right? They're just regular numbers. So negative 7 times 9 is negative 63, right? And our exponents, we're just going to add for our b. So negative 2 plus 7 is positive 5. So our whole final answer, negative 63b to the 5th. For number 4, same thing. We've got exponents that we need to add, and we have coefficients that we need to multiply. So 4 times 2 is 8. B to the 3rd, B to the 4th, we add 3 plus 4 to get 7. So we have 8, B to the 7. Here we have 2y to the 3rd, 3y to the 4th. Multiply our coefficients. 2 times 3 is 6. Add our exponents. 3 plus 4 is 7. Here we have 2 variables, which is perfectly fine. Okay, we don't want to combine x's with y's. We're just still combining x's together and y's together. So our answer here, we're going to add 13 plus negative 4 to get 9. So you have x to the 9th, right? And then negative 5 plus 10 is positive 5. So x to the 9th, y to the 5th, and that's our final answer. We can't put these together because x's and y's are not the same base. Right? So we have to have x's and y's in our final answer. Now we go back to numbers. Exponential form, rewrite with exponents. So 5 squared and 5 to the 3rd. We have 5 to the 5th, right? You add 3 plus 2. And standard form is just solving it out, like 5 times 5 times 5 times 5 times 5, or using that button on our calculator. It would be 3,125. 4 squared times 4 squared, exponential form. 2 plus 2 is 4, so it'd be 4 to the 4th power. Okay, when we actually multiply that out, it'd be 256. Exponential form down here, we have negative 2 to the 3rd times 2 squared. 3 plus 2 is 5. And we'd keep our base, but we want to keep the negative in front. So base is 2, but we have one negative, so we got to keep that there. So then our standard form is negative 32. Here we have parentheses, negative 7 squared times negative 7. Okay, this again would be an exponent of 1 since we can't see it. So we do want to add 2 plus 1, which would give us negative 7 to the 3rd, and I kept my parentheses because it's there, we can't get rid of them. So parentheses negative 7 to the 3rd, which would be negative 343. Hopefully this first one is making some sense. Okay, we're multiplying our coefficients when we have them. 2 times 3 is 6, adding our exponents for our same bases. We're going to get into another rule next on the back of this page. The tricky part is when they all come together. So we need to make sure we got it one piece by piece so that when we're putting it all together, we have to remember all of our pieces. So our next thing that we want to talk about is quotient of powers, and we're dividing like bases. Okay, so this time instead of multiplying, we're dividing, right? We've got our little fraction bar, that means divide, and we're dividing two things that have the same base, and then we have some exponents. Okay, so this first one, if we're going to write it as repeated multiplication, we actually have multiplication on the top of our fraction and on the bottom. So this is what it's going to look like. We have 4 to the 5th is 4 times 4 times 4 times 4 times 4. On the bottom, we have 4 times 4 times 4, 3 times. When we're actually dividing these, we can cancel some of these out. So I'm just going to use a different color to help us see. But if we have 1 4 here, 1 4 here, we can cancel these out, right? We've got 3 on top and 3 on bottom, and then we have 2 left over on top. So then our exponential form is 4 to the 2nd power because that's what we had left over, which 4 squared is 16 in standard form. Okay, we can cancel these out because 4 divided by 4 is 1, right? 4 divided by 4 here is 1, 4 divided by 4 here is 1. And if we're multiplying ones into this, it's not going to change our answer. So we just basically think of them as canceling out. Even though they're really not canceling completely, they're equal to 1, but timesing 1 doesn't change our answer. So we're just canceling them out. Okay, so let's look at another one. Here we have negative x 6 times, and we have negative x twice on the bottom, right? So here's our multiplication. I just put them next to each other. I didn't write the multiplication dots, but it's multiplying, right? And so if we're going to cancel stuff out, we have 1 here and 1 here that we can cancel. I know it's a little weird, I took them from the middle, but it doesn't really matter which ones you use to cancel. We've got 2 left here and 2 left here, so we have 4 left over. It's negative x to the 4th power. Okay, we cross out standard form because we can't solve this, right? We don't know what x is, so this is the best we can do. Okay, negative 3 to the 8th power, because they're not all negative, right? We don't have parentheses around this, so we keep our negative, and then we do 3 8 times. And 3 to the 4th, we've got 4 of those, right? So then when we cancel stuff out, got these, and these, we can cancel out 4. Oop, cancel that out. Okay, so we have 4 left on the top, right? So we have negative 3, because we keep that negative, to the 4th power, which if we multiply that out would be negative 81. Hopefully we're seeing a pattern here too. Last time we were adding exponents, but this time if our bases are the same, we're going to subtract our exponents when we divide, right? 5 minus 3 gives us 2. 6 minus 2 gives us 4. 8 minus 4 gives us 4, right? So we keep our base the same, like here our base was 4, we kept that, negative x, 3, 3, right? But we subtract our exponents when we're dividing. So over here, we were multiplying bases and we add our exponents. 5 plus 4 was 9. But on this side, when we're dividing, we're subtracting our exponents. Okay, so let's see what that looks like. Okay, so if we have n to the a divided by n to the b, when we solve it, we're really going to have our answer as n to the a minus b. Whatever a and b are, we're subtracting them. If we have coefficients, just like on the other side, when we had coefficients for multiplying, we multiplied them like normal. If we have coefficients here, we're still dividing them, right? X divided by y, we keep that. Okay, those are just regular numbers, we still divide them. When we divide our bases though, we're going to end up subtracting our exponents. Okay, again, if this doesn't quite make sense, that's okay. We're going to show some practice down here. Okay, so b to the 8th divided by b to the 3rd, we have the same base, we're dividing, we're going to subtract our exponents. So 8 minus 3 is 5, so b to the 5th is our final answer. Here, z to the 5th divided by z to the 1st power, remember if you can't see it, it's a 1. We're going to subtract our exponents, so we have z to the 4th. 5 minus 1, 4. Now we get into some coefficients. 4 divided by 2 is just 2, right? 4 divided by 2 is 2. And then our exponents on our b, we're going to subtract. 9 minus 4 is 5. So our final answer here is 2b to the 5th. Same thing here, we're going to have our exponents that we're going to subtract, but we have our coefficients that we need to divide. Negative 12 divided by 6 is negative 2. 5 minus 3 gives us y to the 2nd power. The next two are a little bit different. If you notice, these are regular fractions. They're not improper fractions like this one. Okay, so when we divide 15 divided by 35, it would give us a decimal. We don't want decimals in our exponent answers. We want to keep everything as a fraction. So if you had the fraction of 15 over 35 without the exponents over here, like if you were just thinking about the number part, 15 over 35, think about how you would simplify that fraction, right? We can divide by 5 on the top and the bottom. When I move this answer box away, it's actually going to be wrong. I typed the wrong thing in here, but 15 divided by 5 is 3. So this should have been a 3. Sorry, guys. right? 15 divided by 5 is 3. And then 35 divided by 5 is 7. So we're just simplifying that fraction. 15 over 35 simplifies to 3/7. And then our exponents, we're going to subtract. We got to be careful here. We have a negative. 4 minus negative 2 is positive 6. Minus minus becomes a plus. So 4 minus 2 is 6. And that's a positive exponent, so we put it on top of our fraction. Okay, so we simplified our fraction, 3/7. We subtracted our exponents, and then we got x to the 6th on the top. Okay, so let's try this one more time. So here we have 3/18, right? We can divide on top and the bottom by 3, right, to simplify our fraction. On the top, we would just get a 1, which I actually didn't write. Okay, so when you have a 1 in our fraction, you can write it there if you want, but you don't have to have it. So it's up to you. Either way is correct. But so 3 divided by 3 is 1. You can write it there. You don't have to. 18 divided by 3 gives us 6. For our exponents, x's and y's we can't put together. If you notice, I have no x's in my answer. Okay, x to the third and x to the third are going to cancel each other out. 3 minus 3 is 0. And when you have an exponent of 0, this just goes away. Doesn't exist anymore. 10 minus negative 1, well, minus minus again becomes a plus. 10 minus negative 1 is 11. So we have y to the 11th, and that's a positive exponent, so we put it on top of our fraction. And then this was 1/6 when we simplified it. Okay, you got to be careful. Bigger number on top, you divide just like normal. Regular fraction with bigger number on the bottom, we got to simplify that fraction. Okay, here we're back to regular numbers, 5 to the 9th over 5 to the 7th. We're just subtracting like normal. 9 minus 7 is 5 squared, right? 5 squared is 25. That one is pretty simple. Here we're going to subtract again. 10 minus 4 is 6. So negative 2 to the 6th power is 64. Okay, we have one more thing that we want to do in this notes before I let you guys try some on your own. Okay, 0 as an exponent. Okay, this is pretty simple. 0, anything to the 0 power is positive 1. Okay, if it's in parentheses and it's a negative thing to the 0 power, it's still positive 1. The only time it gets a little bit different is if there's no parentheses. No parentheses, instead of being negative, or sorry, instead of being a positive 1, it's going to be a negative 1, because this exponent is changing this to a 1, but we still have the negative outside. So this is going to stay negative 1. When it's in parentheses, the 0 is applying to the negative and to the n, and it's changing all of this to a positive 1. Okay, no parentheses. This part changes, but we keep our negative outside. Okay, so these are actually pretty simple. Most of the time your answer is going to be some variation of 1 or negative 1, unless you're adding and subtracting some things. Okay, so negative 5 to the 0, no parentheses. We're just applying the 0 to the 5, not to the negative, so we're going to keep our negative, and it's going to be a negative 1. Here's kind of the opposite. We have our parentheses, negative 17, everything's in parentheses, so our 0 is changing everything to a positive 1. Here we're going to be adding, so we got to think about these individually. Negative 2 to the 0, no parentheses, is going to stay negative, plus negative 2 to the 0 with parentheses, that changes to a positive, so we have negative 1 plus 1 is 0. Here, they tried to be a little bit tricky. It's not that tricky. 9 minus 4 is just 0. 9 to the 0 power, anything to the 0 power is just 1. Here we have a variable, which is perfectly fine. Variables to the 0 power are still just 1. So with our parentheses, this whole thing is going to change to 1. We're going to do some subtraction here. So we've got negative 7 to the 0 power, no parentheses, so it's negative. We're going to keep our minus in between. 7 to the 0 power is 1, so negative 1 minus 1, our final answer here is negative 2. Here we have negative parentheses 6y to the 0. this parentheses is a little different. Our negative is not inside the parentheses. So our 0 is just applying to the stuff in the parentheses. Our negative is not part of that. So our answer here is actually -1 because that negative was not inside the parentheses. Here again, we don't have parentheses, so this 0 is applying just to that y, so we have a -11. Y to the 0 is 1, so this is really like -11 times 1, which anything times 1 stays the same, so this is just -11. Here we have some addition, so order of operations, right? You would do your parentheses before your exponent, so 2 plus 2 is 4. Okay, and it's in parentheses, and then we've got our 0. Well, 4 to the 0 power, anything to the 0 power is 1. So now down here we have some mixed practice for us to look at. So this is where it gets complicated. These look a little bit more complicated than what we were doing before. It's because you're putting all your rules together. So we're going to work through these. Make sure that you're listening to explanations, writing stuff down, okay, because on this next page you're going to have to do all of these on your own, and some of them are a little bit simpler, but then they get more tricky at the bottom. So make sure that you're understanding these examples. So first thing we have here is our fraction 2/8, right? You have 2/8 if you just look at the numbers, right? We can divide by 2 on the top and the bottom, right? And so your fraction for your numbers would be 1/4. Okay, so treat your numbers just like you would normally. 2/8 simplifies to 1/4. Okay, then we have lots of variables going on. Remember, when we're dividing our variables, we subtract our exponents. So here we can't see our exponents on our x or our y, so they're both 1s. So x squared, x to the first, 2 minus 1 would give us x to the first power. 5 minus 1 gives us y to the 4th power. Okay, so if we look at our final answer here, I put that all together. These are just going to go on the top, right? They have positive exponents. Positive exponents go on the top of our fraction. So we have 1/4, x to the first power. You don't need to write the 1. If you do, it wouldn't be wrong, but you don't have to. And then you have y to the 4th power. Okay. Our next one, we have 9/30. Again, you want to just treat that like a regular fraction and simplify it. I divided by 3 on the top and the bottom. And so when you do that, you get 3/10. Okay, so that's what our fraction would be. Now we have all x's. We have x's on top and x's on bottom. So what I do is when I have x's together on top, I put those together first before I worry about combining it with the ones on the denominator. So when they're together up at the top, they're being multiplied, right? And when we multiply like bases, we add the exponents. So on the top, we have x to the 8th power, and on the bottom, we have x to the first power, right? We added our exponents, x to the 8th, and now we're dividing them as our final step. So remember, when we divide, we subtract our exponents. So 8 minus 1 is 7. So this is our final answer. We have the 3/10, and when we subtracted, we got x to the 7th, positive exponent, we're going to put it on top. So 3x to the 7th over 10. Okay. Again, see, it gets a little bit trickier when we're putting it all together. Okay, so we just got to take it piece by piece and remember our rules. Multiplying, we're adding our exponents. Dividing, we subtract them. Okay, here we have 10/2. Well, 10 divided by 2 is just 5, right? That one's a nice, easy, simple division. We don't have to simplify, we're just dividing. X to the 0 power is 1, so that's like saying 5 times 1. Well, that's just 5. So we don't really need to do anything with that. Y to the 9th divided by y to the -7th. Remember, when we divide, we subtract. So 9 minus -7 becomes a plus, and so we get y to the 16th. So our final answer here is 5y to the 16th. We don't have a fraction like our other two because we divided and got a nice whole number. We don't have fractions left over when we simplify like these did. So we just have 5y to the 16th. Okay, the next one, again, we're not going to have a fraction when we finish because we're going to divide and get a nice whole number. -6 divided by -2 is +3, right? Negative divided by negative is positive. Okay, then we have A's and B's, but we have two A's on the top, right? So we're going to combine those. 11 and -5. We're multiplying the bases, so we have to add the exponents. 11 plus -5 is +6. And B has nothing to combine with, so that just stays the same, and it's B to the third. Next one here, we have -8 over 24. Well, -8 over 24. That does not look good. We'll fix that. -8 over 24. We can simplify it by dividing by 8. So that'd be -1 over 3. Okay, so we're going to have a fraction because look, we have a fraction, we had to simplify it, right? Then we have all A's. So the first thing we want to do is combine all the ones on the top. So if we're multiplying these on the top together, we're adding our exponents. -2 plus 13 is 11, plus 5 would be 16. So we have a to the 16th divided by a to the 7th. Well, when we subtract, 16 minus 7 is a to the 9th, and that is positive, right? So we're going to put that on the top. So we've got -1 on top, 16 minus 7 was 9, so a to the 9th over +3. Okay, here we have -8 on the top, -8 squared on the bottom, well that's just 64. So then we have -8 over 64. So then what we can do is divide by 8 on the top and the bottom. When we divide by 8, we're going to get -1/8. Right? So that's going to be a fraction in our final answer. We're going to add these exponents together because we're multiplying them. -12 plus 10 is -2. Plus 5 is 3, right? So we have x to the third on the top and x to the first on the bottom. So x to the third over x to the first, we're going to subtract 3 minus 1 is just x to the second. So positive exponent, we put it on top, we have -1 over 8, x to the second power. Okay, we're almost done. We're almost done. We have -6 to the third power. That's just -6 times -6 times -6. It's -216. -6 to the fourth power, we multiply one more -6, we get 1,296. Okay, when we have a negative number, if it's an odd exponent, it's going to be negative. It's an even, it's going to be positive, right? It flips back and forth from positive to negative. This one, even though it's an even exponent, look, there's no parentheses here. So -6, we just leave that the way it is. So we have the negative out front, and 6 squared is 36. Last one we're doing together, we're going to use our exponents to change these to ones and negative ones. (12 to the 0 power is +1 plus -12 to the 0 power in parentheses is also a +1 minus 12 to the 0 power again is a 1 minus -12 to the 0 power in parentheses is a +1, but we're going to keep that minus from out here. 1 plus 1 is 2, minus 1 is 1, minus 1 is 0. Okay, on this next page, you are going to try these. Then you're going to get them checked by me when you are done. If you have anything to fix, I'll circle it and you'll go back and fix it. If you have questions on these, please ask, but use your notes to help you, right? We filled these in for a reason. We need to remember our rules. When we're multiplying bases, we add exponents. When we're dividing bases, we subtract. Good luck.